Hi, welcome to another venture of Mr. Lamb. Today we'll be talking about matrices. So the course outline for today will be transition matrices and applications, the steady-state solution, and important cases. So the first skill we're running through is the transition matrices and the applications. So in terms of a transition matrix, the figures inside of it are written as decimals. The columns of a transition matrix always adds up to 1, very important. And the order is also very important in the sense that if the top is written A then B, then the column must also be written A then B. So here's an example of a transition matrix. As you can see, the columns add up to 1. And this part is from, and this part is to. So it's from A to B, and from A, or maybe from B to A. So using a recursion to generate matrices step by step. So this is similar to the recurrence relations done in core, but we're using matrices. So we've got for our recurrence relation rule there, S0 equals to initial value, Sn plus 1 equals to T, which is called a transition matrix, multiplied by Sn. We can use this recurrence equation to work out how objects change over time using a transition matrix. So for example, in Melbourne, 50 people use trains and 50 people use cars. This is what we call the initial value, so S0. 50% of people traveling using cars will continue to use cars the next week. And 20% of people traveling using trains will change to using cars the next week. So we can transform that information into a transition matrix, T. So I've decided to use trains first and then cars. So trains, cars, and then on the vertical side, put it in the same order, so trains and cars as well. Now it says 50% of people traveling using cars will continue to use cars. So from cars to cars is 50%. 50% as a decimal is 0.5, as you can see here I've written 0.5. The next part is 20% of people traveling using trains will change to using cars the next week. So from trains to cars is 20%, otherwise 0.2. Now we don't have every piece of information, but the most important fact is that each column adds up to 1. So if I know that trains to cars is 0.2, then the remaining, which is 0.8, will be trains to trains. And the same with cars to trains as well. If we know cars to cars is 0.5, then cars to trains is 0.5 as well. So as you can see, after 1 week, S1 is equal to the transition matrix multiplied by S0. And then for week 2, you just go S2 equals the transition matrix multiplied by S1, which we worked out here, and that will give you S2 after the second week. Now, here's a much better formula for large values of n. You can use this one here. It's similar to the rule in recurrence relations. So 2016 Federal Maths Exam 1, this is question 6. You're given a transition diagram and you need to find a transition matrix that provides the same information.
Hello, so this is 2016 Federal Maths Exam 1, question 6. Families in a country town were asked about their annual holidays. Every year, these families choose between staying at home, traveling, and camping. The transition diagram below shows the way families in the town change their holiday preferences from year to year. So as you can see, staying at home, 30% of the people stay at home each year. 45% of those that stay at home will go traveling, and 25% of those that stay at home will change to camping each year. So the question is a transition matrix that provides the same information as the transition diagram is. So some key information is that a transition matrix must add up to, or the columns must add up to 1. So having a look at that, you can see that A is not the correct answer, as 0.65 plus 0.2 plus 0.6 is more than 1. This one's also wrong, 0.4, 0.2, 0.6. This one, 0.25, 0.2, 0.6 is too much. That leaves, just checking these ones off, these two answers here. So have a look at which one strikes out the most. I see the 0. So the 0 strikes at the most is from C to T. So it's saying that from camping to traveling each year there should be 0. So let's have a look. From camping to T, there doesn't seem to be any arrows going from C towards T. However, this one says from C to T, from camping to traveling is 0.2. However, I'm assuming they're referring to this. This says from traveling to camping. So this one's not right. That means the answer must be B for that one there. So that's it. Thank you very much.
Okay, moving on to the next one. So the next one, we've got 2016 Federal Maths Exam 1. This is question 7. Based on the information above, it can be concluded that in long term, you need to see what's happening in this story. We'll have a quick video. Let's have a look.
Hello, so this is 2016 Federal Maths Exam 1, question 7. Each week, the 300 students at a primary school choose art, music, or sport as an afternoon activity. The transition matrix below shows how the students' choices change from week to week. Based on the information above, it can be concluded that in the long term, so the key word is long term. Long term, you're looking for a steady state. So the formula was Sn equals T to the power of n times S naught. So let's have a look. We've got a transition matrix, that one. We don't know how many students there are that pick art, music, or sport. However, in the long run, it doesn't really matter what we start off with. So we're going to put the transition matrix down. And we're going to multiply it by, let's say 100, 100, 100. Once again, it doesn't matter what it is because in the long run, it will all become the same anyway. So let's have a look. So we need to bring up our matrix. It's 3 by 3. 8.5.4.1. Just a reminder, I use the tab button to go across. It just makes things a little bit faster and smoother. And we're going to raise that to a power of, I normally raise it to a power of 100. So 3 rows by 1 column. Now I'm going to put 100, 100, 100. Oops. That should be 100, not 10. Okay, so we've got, when we multiply that out, we get 104.7, 109, and 85.7-ish. Okay, now just to check steady state, let's change that 100 to 150. And as you can see, the numbers don't change, so that means we've hit steady state. So let's go through this. It's not A because A was art. The next one was music, sport. So some people do pick sport. All students will choose to stay in the same activity each week. That's not true because there's a transition matrix. All students will have chosen to change their activity at least once. That's also incorrect because this week, from this week picking art to next week picking art, that's 50% of the students picking the same subject. More students will pick music than sport. That's currently true. As you can see, 109 to music and 85.7 to sport. So that's a possible answer. And the number of students choosing to do art and music will be the same, and that's obviously not right. There's more people doing music than art. So the answer is D. Thank you very much.
Okay, moving on. So we have 2 questions. We've got now 2017 Further Maths Exam 1. In this question, we've got a recurrence relation, and we need to find out what happens each month to the fishing farm.
Die. Juveniles may eventually grow into adults, or they may die, and adults eventually die. The initial state of this population F0 is shown here. Every month, fish are either added or bought so that the number of young, juvenile, and adult fish in the farm remain constant. The population of the fish in the fish farm after n month, Fn, can be determined by the recurrence rule, this one. where B is the column matrix that shows the number of young, juvenile, and adult fish bought or sold each month and the number of dead fish that need to be removed. Each month the fish farm will. So for this question, you kind of need to work out what B is. Now, the key word is that it remains constant. So even after 1 month, what is it, 1 month? Yes, even after 1 month, this number doesn't change. So if we were to set up a matrix equation, it would be 50,000 equal 10,000, 7,000, and 0 is equal to the transition matrix, so 0.65, 0, 0, 0, 0.25, 0.75, 0, 0, 0, 0.20, 0.95, and 0, and then 0.1, 0.05, 0.05, and 1. And that's multiplied by Fn. Now Fn in this case is going to be the initial state matrix. So 50,000, 10,000, 7,000, and 0. Plus B. So this is for 1 month. So we're solving for B. So in this case, it would be this matrix subtract this multiplication. So I'm going to multiply this part out first. So that's a 4x4 matrix. 4x4 matrix, which is 0.65, 0, 0, 0, 0.25, 0.75, 0, 0, 0, 0.2, 0.95, 0, 0.10, 0.05, 0.05, and 1. So that's going to be multiplied by the initial state matrix, this one here, which is a 4 by 1. So that's a 50,000, 10,000, 7,000, and 0. So I'm going to multiply that out first, and you end up with that number there. So you end up with, let's go up here, you end up with 50,000, 10,000, 7,000, 0 equals to 32500, 20,000, 8,650, and then 5,850 plus B. So to get the B by itself, we kind of need to move this matrix to the left hand side. Now all these numbers, this is a positive matrix, so when we move it to the other side, it will become a negative matrix. So in terms of on the CAS, because there's no more room to write, it will be the initial state matrix. So this one here, the 50,000, 10,000, 7,000, 0. Subtract what we've just worked out, and that will give you matrix B. Now the next thing you have to interpret is what's happening in each one of these numbers. In the first one, it says we need to buy 17,500 young fish. So looking at buys is none of that and none of those two. The minuses means that we need to sell. So let's see, it was young, juvenile, adult, and dead fish. So in this case, we need to, young fish is the first one. Since it's positive, it means we need to buy. So it's not exactly sell that either. If we look at the adult fish, which was the third row, that's negative 1,650, and that means it's a sell. So that means the answer is A. We need to sell 1,650 adult fish to keep this constant. And that's it. Thank you very much.
And that was 2017 Further Maths Exam 1. Hi, so this is 2017 Further Maths Exam 1. Let's have a look. So question A, consider the matrix recurrence relation below. Matrix T is a regular transition matrix. Given that the above and the S1 is equal to that, which of the following expressions is not true? Let's have a look.
Hello, so this is 2017 Further Maths Exam 1, question 8. It was the last question, it was probably considered a harder one as well. So consider the matrix recurrence relation below. Matrix T is a regular transition matrix. given the above and that S1 is equal to that, which one of the following expressions is not true? So we've got the transition matrix multiplied by S0 to give S1. And we have to find out what X, Y, Z, W, and V are. Now, the easiest ones to find are X and Y, because hopefully you remember that the columns must add up to 1. So that means X is to be 1 take away 0.3 take away 0.2, which gives 0.5. So X is 0.5. Now Y would be the same, 1 minus 0.2 minus 0.2, which equals to 0.6. So X is 0.5, Y is 0.6. Now, the next one is V, W, and Z, and they're a little bit harder to work out. This is where you need to know your matrix multiplication. So if I was to redraw this, 0.3, 0.2, V, W, Z, 0.2, 0.2. Now we know that this is 0.5 and 0.6. That transition matrix is multiplied by S0, which is 40, 15, and 20, to give 29, 13, and 33. So you can make the following equations. So hopefully you remember 0.3 by 40. So to get this 29, it will be 0.3 times 40 plus 0.2 times 15 plus V times 20 to make 29. So then you can get your CAS out and use the solve function or work them all out individually. It's up to you. I'm going to use the solve function. So menu, algebra, solve. 0.3 by 40 plus 0.2 times 15 plus V times 20 equals to 29, comma V to solve for V, and the answer is 0.7, so V equals to 0.7. And you repeat that to find W. So to get W, it will be the second row, so it'll be 0.2 by 40 plus 0.2 by 15 plus W times 20 equals to 13. And then you work it out using solve again. So this time it is menu 3.1 solve. So 0.2 by 40 plus 0.2 by 15 plus W by 20 equals to 13, comma W. And we get W to be negative 0.125. So something's gone wrong with my calculations there. Here it is. I typed 0.5 times 15 when it should have been 0.2. And W equals to 0.1. So we know that V is 0.7, W is 0.1. So remembering the whole column needs to add up to 1. So that means Z will be 0.2. So we've got all the numbers. So X 0.5, Y is 0.6, V is 0.7, W is 0.1, and Z is 0.2. Then we just need to go along and check all these. So which one is not true? So if I add up X, Y, and Z, is it greater than 1? Yes, because X and Y is already 1.1, so it's not D. VWZ equals to 1. That's true, because the columns must add up to 1. This one says V is greater than Y, so V, which is 0.7, is greater than Y, which is 0.6. That is true. B, Y is greater than X. That's also true. 0.6 is greater than 0.5. And this last one says W is greater than Z. So 0.1 is greater than 0.2, which is untrue. So the answer is A for that one. So in this question, you just have to be very careful. You need to know how to do matrix multiplication. And that's it. Thank you very much.
Okay, moving on. So here we've got 2016 Further Maths Exam 2. So this was the short answers. Travel company is studying the choice between A, L, S, and N by some of his customers. You've got transition matrix here, you've got initial state matrix, and the question is asking you to find D, E, and F. We'll have a look at a short video.
Hello, this is 2016 Further Maths Exam 2, question 3. So this is a short answer question. The travel company is studying the choice between air, land, sea, or no travel by some of its customers each year. Matrix T shown below contains the percentages of customers who are expected to change their choice of travel from year to year. Let Sn be the matrix that shows the number of customers who choose each type of travel n years after 2014. Matrix S0 below shows the number of customers who chose each type of travel in 2014. Matrix S1 below shows the number of customers who chose each type of travel in 2015. Write down the values missing from S1, D, E, F in the boxes below. So first one is simply just a CAS question. You need to bring up the transition matrix, which is a 4x4. So that would be 0.65, 5, 0.15. Make sure you type it in correctly the first go. It always saves you a bit of trouble. And you just need to multiply by the initial state matrix, which is that one there, S0. So that's a 4 rows by 1 column. So that will be 520, 320, 80, and 80. So hit enter, and then you should get those numbers there. So in terms of D, the answer was 298, 94, and 130. So that wasn't too hard. Step B, write a calculation that shows that 478 customers were expected to choose air travel in 2015. So this time you need to actually write the calculation. So I'll just draw it out here. 65252550. And I'm only going to do it for the first row because it's for air travel and just to show you how to do matrix multiplication. Okay, so that's the row A, and that's the initial state matrix S0. So hopefully you remember in terms of matrix multiplication, it's the row by the column to get that number there, 478. And what we do is we take the first number in that row, so 0.65, multiply by the first number in that column, 520, plus the second number, multiplied by the second number, 320, plus the third one, multiplied by the third one, plus the fourth one, multiplied by the fourth one. So first number in the row, multiplied by first number in the column, plus second number in row, times second number in column, plus third number in row, times third number in column, plus fourth number in row, times fourth number in column. So the answer would be 0.65 times 520, plus 0.25 times 320, plus 0.25 times 80, plus 0.5 times 80. Now the question says write a calculation, so we'll leave it at that. But always good to check your answer. So 0.65 by 520 plus 0.25 by 320 plus 0.25 by 80 plus 0.5 by 80. And as you can see, the answer is 478. And that's it for that question. Thank you very much.
Okay, we'll keep moving on from there. So this is 2017 Further Maths Exam 2. We've got a transition diagram and we need to answer some questions regarding that. Stay tuned to the video.
Hello, this is 2017 Further Maths Exam 2, question 2. So, junior students at this school must choose one elective activity in each of the 4 terms in 2018. Students can choose from the areas of performance, sport, and technology. The transition diagram below shows the way in which junior students are expected to change their choice of elective activity from term to term. Of the junior students who chose performance in one term, what percentage are expected to choose sport next term? So we're looking at performance, and what percentage is going towards sport? That is 40%. Alright, moving on to part B. Matrix J1 lists the number of junior students who will be in each elective activity in term 1. 306 junior students are expected to choose sport in term 2. Complete the calculation below to show this. So the 300 represents P, the 240 is S, and the 210 is T, as you can see. So we're looking at the amount that goes towards sport. So the P, as you can see, is 40%. Now, just keep in mind it's 0.40, if you like. For the S going towards, well, S going back to itself is 60, which is 0.6. And the 210 is from T, so that's 20% of it, so 0.2. And that should equal to 306. Now part C, in term 4, how many junior students in total are expected to participate in performance or sport or technology? So when we're looking at this question, hopefully you realize that everyone does something. Everyone will do performance, technology, or sport. There is no people that, or no students that get themselves removed from the program, or they pick something else. So in this question, how many junior students there are? There will be whatever started, whatever the initial amount was. So it'll be the 300 plus the 240 plus the 210, which equals to 750. Because everything's enclosed. There's no students that can't drop an elective, and there are no students that pick an elective that's not in this transition diagram. So that means the total number of students is always constant, is always going to be the same, which is 750 each term, because there's no students in here. And that's it. Thank you very much.
Okay, let's keep moving on. So the second skill we're going to talk about is the steady state solution, otherwise known as the equilibrium state, and it can also be talked about the long-term values. So the steady state solution, when the values eventually come to the same numbers, regardless of what n values substituted, means that the equilibrium state has been reached. So in terms of doing transition matrices, as you do more and more, eventually you'll get to a fixed number. The steady state solution can normally be found by substituting a very large value of n into the rule. And to confirm the steady state, two large values of n are used, and two values are separated by a certain amount of numbers. So for example, don't use 10 and 11, use something like 100 and 150. So for example, here I've got 0. This is my transition matrix. It's raised to the power 50, and I end up with these values here. Normally you'll have an initial state, but I've left it out. It doesn't really matter too much. So this transition matrix, 2 by 2, raised to the power 50, I end up with these numbers here. Now if I do the same question and I raise it to about 100, as you can see, these numbers don't change. So that means I've reached the steady state solutions. So for there to be a steady state, the transition 1 must be regular, and the columns must add up to 1, as per usual. And a regular matrix is one that has no zeros when raised to a power. So just keep in mind the steady state solution is when you raise the transition matrix to a very high power and the answer does not change when you raise it to another high power. So as you can see here, once again, I raised it to 50, that's what I got. I raised it to 100, that's what I got. That means I've reached a steady state solution, or the long-term values. I've got transition matrix modeling using the rule Sn plus 1 equals to T multiplied by Sn plus B. So this is kind of like your recurrence relation with paying an extra amount or removing an extra amount. So if a recurrence relation is given to you, just a reminder, you must use the recurrence formula. Unfortunately, there are no shortcuts. So for example, if I've got a recurrence relation here, Sn equals to T times S plus B, where my transition matrix is that, my B matrix is that, and my S matrix is that. So to work out S1, I will need to put the T, the S, and the B, and I'll get an answer. To get S2, I need to reuse this recurrence relation. So to find S2, I'll have T, which is the transition matrix. I'll have S. Now, if I'm finding S2, it'll be S1. That goes in here. So I need to take the answer from the previous recurrence relation, plug it into here, and then continue on from there. So plus matrix B, which is that one there, and I'll end up with this answer here to decimal places. So just keep in mind, it's very important, if a recurrence formula is given to you, you must use it. And the first skill I'm looking at is just some important cases. So matrices can only be added or subtracted when they have the same order. Very important. It will save you a lot of time. If there are 3 matrix multiplications, you need to check the order from left to right. For example, if I'm looking at matrix P, and matrix P is matrix Q multiplied by matrix R multiplied by matrix S, and it is defined, which means I can actually do it. And we know that matrix Q and matrix S are square matrices. So Q and S, this one here and this one here, are both square matrices. Now, this is a generic question, and there can be lots of solutions. So I'll have a run through it. So this means that Q and S are either 2 by 2 or 3 by 3. We already got up to a 4 by 4, but touch wood, nothing like that happens. So we're going to assume that's a 2 by 2 or a 3 by 3. Now, scenario 1. If Q is 2 by 1 and S is 2, if Q is 2 by 2 and S is 2 by 2, then R must also be 2 by 2, because in between each matrix must be the same. So we know that Q is a 2 by 2, S is a 2 by 2. So for this part here to be defined, then this must be a 2, and for this part to be defined, this must be a 2, which means R must also be a 2 by 2 matrix. Scenario 2, if Q is 3 by 3 and S is 3 by 3, then R must be 3 by 3, just simply because of the same situation in scenario 1. Scenario 3, if Q is a 3 by 3 and S is a 2 by 2, then R must be a 3 by 2, because in Q, which is a 3 by 3, this and this number, these two numbers here must be the same, which causes R to have 3 rows. And in the second multiplication, these two numbers must also be the same, which causes R to have 2 columns. So that means R must be a 3 by 2. Scenario 4 is the reverse, which means R will become a 2 by 3 matrix. Just some other things. Square matrices are the only ones that can have inverses. And any matrix multiplied by an identity matrix is itself. And just a summary of what we've done. What is a matrix? Using matrices to represent information. Matrix arithmetic. Binary permutation, communication and dominance matrices. Inverse matrices. Solving simultaneous equations. Transition and steady state matrices. And that's pretty much it. Thank you very much.